Hello and welcome to Ismail Badran channel again, and today we're starting with this research skills series. We're going to start with the research skills 1. In this today we're going to actually look at Origin. It's a professional graphing program that used by many scientists. So we're gonna take a look at downloading a free version of an official version of OriginPro. And we're going to go over basic graphing and plotting. We'll take a look at how spectrum and the peaks looks like, and then we're going to cover linear fitting. And the most important thing is the non-linear fitting and its importance in sciences. So the first thing is you need to obtain, by the way, this is Origin. Just want to show you how the program. And by the way, this is Origin. This is how the program looks like. It's a nice really nice professional software. By the way, it's the industry standard for graphing right now. So the first thing you need to know is this is a commercial software that you need to buy, but you can obtain a free student version for a short time. So the first thing is you go to the software website. It's originlab.com. So this is the main page of Origin. You need to register with them using an official university email. They don't accept any generic emails like Yahoo or Gmail. So you need to use your school or company or whatever official email that you have. So in this case, I have registered with my official username, which is ibadran.najah.edu. The next thing you need to do is you need to log in and go to the support page. Okay. So in the support page, you go to Origin Trial. That's right here under Downloads. So click on Origin Trials, and then it will ask you a couple of questions. So you say if you own Origin before or anything. So I'm just gonna say as I have never used Origin, and you click Student. If you're a faculty, you can choose that too. Click Continue, and here you have two choices. You have either trial version, okay, that will give you 21 days, or a student version, and that will give you 6 months, and actually you can even extend that if you like. And then you click here, Request Learning Edition, and now you fill up the information, your email and the university, whatever reason you for that, and then you click here, I have read and agree, and then click Submit, and that will send them a request to obtain a copy of Origin. And then soon you will receive an email that you can download and install the program to your computer. So in here I have a fully activated version of Origin Pro. Okay, once you install Origin, by the way, there are here some really helpful tutorials and videos that can teach you a lot of things of Origin. Origin is a huge program that does a lot of things, including statistical analysis, plotting, graphing, curve fitting, a lot of things in here. So you can, depending on what you want, here are training videos on how to import data and do different things. And there's also a learning center that you can benefit from. But anyway, in our case, we're going to start with something simple, and we will start with a spectrum. So people in physics and chemistry, they do that a lot. So here I have data. It's a mass spectrum data between the x-axis mass over charge, and you have intensity in the y-axis. So I got this data from it's real data from my PhD. So I'm gonna copy this 2 columns, and you can paste them here into Origin. And in here, once you open Origin, it will open a sheet. Okay, it's a single sheet right now. You can copy your data in here. Here you have the long name, units, and comments. So these should go here in the long name, okay, and you can add the units. So intensity, the mass of charge has no units, and the intensity has arbitrary units. So I'm going to say arbitrary units, okay. If you have centimeter, you have meter, you have kilogram, you can put the unit here. So no comments. I'm just gonna copy these numbers from Excel or from whatever source into here. So now I have my data. So I'm gonna right away go, because this is a simple tutorial, I'm just gonna go ahead and right away make a graph of this. I'm gonna select these 2 columns, okay, simply, and spectra will take a line. So you have three options between align or scatter or both. So I'm gonna just choose align in here, and boom, I have a spectrum, a nice spectrum. So before we move on, I advise you very strongly to name your windows inside Origin, because at the end you'll have a lot of sheets and a lot of graphs and you get lost. So the way you do this is one of the ways to do that is you right click on this blue bar here, right click, go to properties. So I'm gonna just simply call this mass 1, or sorry, spec 1, whatever, just give it a name. Just copy this down here too, click OK. Oh, that's my data, so I'm actually go again and click this spec data. Okay, 1, whatever name, just to allows you to keep track of your graphs in Windows. So this is the graph for this data, so properties, and I'm gonna call this spec graph 1, or if you like, whatever naming system that you establish for yourself. So now I have in this window here, I have one sheet, or one data sheet, and one graph. And by the way, sometimes when you open Origin, this window might be here or there, or it might be actually hidden like that. So the way you show it again, and it's very important to show this, is I remember that you have to go to View, and in here there's something called Project Explorer. So you need to show this. So this is your window, and then you can grab it and put it wherever you like. And the way I like is I put it in the down here. So now I have my windows and our working area. Okay. So next, I have peaks here, and a lot of peaks. So I need to select these peaks, or what we call peak picking. Okay, and this is nice for people who work in the fields of chemistry and physics and engineering. So the way you do that is right away you go to analyze, and here there are a lot of things that you can do in analyzing. Okay, you can find the area under a curve, you can integrate, you can do fitting. So the one we need right now is we need to go to peaks and baseline, and you go to peak analyzer, and then you always open a dialog. Don't use this, okay? And that will give you a dialog that asks you a couple of questions. There are a lot of details in these windows and the way you choose the peaks, so I'm just gonna do a quick basic one right now. So I always remember in Origin, you always, when he asks you something as a manual, you always change it to auto. That's something I will show you the benefit of this later on, but whenever it says calculate, choose auto in all options of Origin. So what I'm gonna do is find peaks. We're going to integrate, choose here. You can create a baseline, by the way, first, and then you click find peaks. So I'm just gonna do the easy one, find peaks, and then click next. Okay, and whatever default options, I'm gonna click next and finish. And by the way, as I said, there are a lot of details here that you can try yourself later on, but let me show you. Oh nice, so now we have peaks. So the program chose the peaks for you. So there are two things here I need to do to improve this graph. So the first thing, there's so much empty white space here which I don't need, so I'm gonna cut this graph at around 400. So the way you do that, and this is something that you need to learn in Origin, is double click the numbers here in x-axis, and you go to scale. Okay, and you change the scale. So let's do that from 0 to 400. That's the horizontal scale, and you click OK. Nice. Maybe this peak's too high, and you need to rescale the y-axis a little bit. So, and there's also too many numbers here, so I'm gonna change also the scaling in the y-axis. So again, sorry, that's left axis, and then scale. We're gonna go from, let's say, yeah, that same number as here, but instead of 0.106, do it 0.02. Let's see, and then before you click OK, you can always apply. You can click apply and see. Okay, now it looks good, but I have so many numbers here, so I can maybe change the increment instead of 0.02, maybe 0.05. Let's see how that sounds. Whatever you like, okay? So just make it nice. Okay, click OK. One more thing in Origin is that this is called the legend. If it's important for you, you can keep it. If you just don't want to see it, you can just delete that, okay? So click on it and click delete in the keyboard. That will take it off. This is, if you double click on that, that will give you some code. You can actually change, you can write your own code, but what I advise you to do is, if you wanna choose different units, go and change it in the table. So you see here this icon that will minimize this. So now I am back to this window. If you want to change the axis labels and units, just change them from here. So see what I'm gonna do here. So let's say M over Z, for example, whatever. See, that will change it right away. Okay. Next, in here, nice thing to do is you click once on this, and that will bring you. And next thing we need to do is we need to make a border for this. So if you click once here, sometimes it does not work. I don't know why in my Origin, but you keep clicking, and you see this labels here. I'm gonna choose this one, which is the borders, and now my graph has borders from all over the sites, which is nice for people who work on publications. Of course, as I always advise you, you have to save your work. So we forgot to save our work. So right now the file is not saved, and you see a star here that tells you this is not saved. So of course we need to save this before we carry on. And you just go and save project, okay, or save project as. Doesn't matter because we're saving for the first time. So we're gonna save this project, and you save it in some place that you know in your computer, as I always advise you, and you give it a name. I'm not gonna save it now because this is just a tutorial. Okay, nice thing to do here, if these numbers are annoying to read, what you can do is you can actually format these numbers to look better. And the way you do this is you go to the original sheet that you have, okay, in here, because oh sorry, no. And the way you do this is that these numbers are actually saved in a sheet, but it's not this sheet. Origin, if you notice here, has created two further sheets. This is a new. They were not here before. This is the baseline numbers that he used to create this baseline. Actually, I can delete this. I don't want it for now. And now you have peak content. So this is the peaks. This is your peaks. This is the numbers that he used, or the program used to create the XPs. So what I'm gonna do is that I'm gonna click here, right click, and go to properties. And in the properties, there's a lot of details here, but it says here that you have displayed as decimal 1000. You can change this if you like, but we'll just give it decimal. But we need to reduce the number of decimal places. So instead of, I'm just gonna go with one decimal place. Again, click OK, and see what's happening here. He actually made it much better. And you see this peak has not been picked. So what you can do is you can go back and repeat the peak picking again with different options, or you can actually add this to the datasheet manually. One nice thing to do in Origin to help you working with files is that you can zoom in and out using your mouse and the keyboard. So what you can do, and this is same thing in many programs, you can hold Control on the keyboard. Right now my finger is in the Control button, and I'm using the roll mouse. I'm using the middle mouse, and you see now I'm doing this. If you want to get out of this, you can click Control W for window. Control W, that will bring you to the. So that's good. I have now a nice figure that maybe I want to put it in my thesis or my paper. So what you can do, you can actually just click in the white space here anywhere, and go Control C for copy, and you can just paste this into your Microsoft Word. And you can paste this into your Microsoft Word. So Control V, and now you have a figure. And now you have a figure in Microsoft Word that you can label and continue with you. The next example is about linear fitting, and linear relationship is very common on STEM areas. STEM is science, technology, engineering, and mathematics, and many people do linear fitting all the time. So I'm having here a simple example of a relationship between the concentration and absorbance, and these two variables, the dependent and independent variables, are managed or controlled by what we call Beer's law in chemistry. So you have basically, this is your x and this is your y, and they're governed by a linear relationship. So you have these experimental data between concentration and absorbance, and what I'm going to do, I need to do a linear fitting and then find the concentration of an unknown value that has an absorbance of 0.85. Many people can do this in Excel, but the way you do it in Origin, which is more professional, is that same thing. You take these data. By the way, in Origin, you don't have to open a new project to do more fitting. What you can do is you can actually make more sheets. Okay, so there are different ways to make more sheets, but if I just right click here and I go new, that will give you no, that's, and if I click just right here and I go new window, that will give me many options. I'm going to click worksheet, so I have a new sheet to work on. So like just like Excel. Okay, so for this sheet, I'm going to bring my data, the x and y, and put it here. And it's very important, by the way, to arrange them like that. And now I'm going to bring also the long names or the labels. So concentration is mole per liter. Absorbance is also arbitrary units. Okay, and that should be good. And as I said before, you can just select these two columns and make a graph. So basically these points should make a nice line. So before I go further, I need to remind you to name your sheets and graphs. So I'm gonna call this sheet calibration curve data. Okay, I'm gonna copy and paste the name up and down, and this is my graph. The reason you need to do that is you need to organize your work, because if you want to it's important, if you want to communicate this file to somebody else, like your supervisor or your colleague, he or she needs to know what you are doing. Even you, like you want to communicate with yourself. Imagine that you have so many sheets and graphs here and so many files, and you want to open this like a year from now. You won't remember what you were doing. But if you name everything and you organize everything, that would be easy for you and people to follow what you are doing. So now we need to do a linear fitting for these points. It's straightforward. You go to analyze. There's something called fitting. There's so many ways to do fitting. The one we're gonna go today is linear and nonlinear. So the way you do fitting is you go to analyze and then fitting. I'm gonna click linear fitting. Again, open dialog. And remember, I told you about this before, the recalculate. So you need to do this, change this into auto. That's something you have to do. Remember, okay? So much options again. Just gonna leave all of that and click OK. Straightforward. Okay, so it's working. Perfect. Now I have a table here with all the fitting information, and this is not something you can get in Excel. Okay. Now these numbers, which include the slope, the intercept, the adjusted R square, and all of that, that you won't see these details in other programs, and that's the nice thing about Origin. If you by mistake or you want to get to if you don't this table to be here actually, or you want to just take it out, you can actually delete it, because this table is now saved inside these new graphs. You see here, this is your original sheet that you have the data on. Now he create a sheet that has all of everything you want, okay? And if you know about statistics, you might be interested in the value of r squared that is not like, there's 3 different r squares here. The Pearson's one, the r square, and the adjusted r square. And by the way, in the options you have all the other ones as well if you are interested. Anyway, I have my linear fitting here. I don't need this table a lot at all. So what I'm gonna just do, which is something I always do, I bring the t, and I want to write here that y is equal mx plus b. In this case, the slope is what? Is 26.4x plus, what is the intercept? Oh, it's the intercept is minus, so I'm gonna minus 0.084. So that's my equation. That's the only thing. Oh, maybe I need the r square as well. So r square is equal to, I'm just going to take the adjusted r square, so 0.9763. So that's what I need. Maybe I don't need this table, I don't need this legend. And maybe, and here you can actually format this r square. There's something here that tells you, oh, here it is, okay? Everything here, it's a very nice program, okay? I make this a bit bigger, so, because you want people to see this. And there you go. And then again you click, remember you have to make you have to add the borders, so click and add your borders. Very nice, very professional graph that you can add to your thesis or your paper. So that's linear fitting inside Origin. Actually you can also okay, remember I told you about the auto calculate. See what's happening, okay, if you change these data. Now let's say instead of 1.3 I have here, let's say 1.6. Oh, okay, it's too much. Okay, 1.3, 1.2. So now what happened is as the moment I changed the number, he recalculated everything because I chose auto inside. He didn't change this equation because this is a manual equation. But if you go to the parameters, the fitting parameters that you have, they should have changed. Okay, the slope and the intercept and so on. So this is a nice thing in Origin that he updates the data as you go. If you didn't do that, if you click manual, then you have to click this white thing here and you have to recalculate. The recalculate is grayed out here because we already select auto. But if it could have been manual, you have to recalculate everything. And for the fitting, some people may ask, how do we delete a fitting? How do we start again? Well, the way you do that, don't delete these sheets like that. The way you do this, if you want to delete a fitting and you want to keep the data, you can click here and say delete. That will delete the fitting with the sheets. See that? And then you can, that will allow you to start again. The next tutorial will deal with nonlinear fitting, and to give you the idea here, let's talk about an example of radioactive decay. Radioactive decay is a very well phenomenon in science that you have a sample of a radioactive element or a radioactive sample, let's say with 100% concentration, and with time this sample will lose its mass and it will become like 90%, 80%, 70% as time goes, okay? And this phenomena, for people who knows chemistry and physics, it follows what we call first order kinetics, okay? Using this equation, where the concentration, which is a variable, it's changing, it's the y, equals the A0, which is the original concentration, this is a constant, times the exponential of minus lambda t, where t is the time, it's your x, okay? It's your dependent variable. And this lambda is a constant. You can call it lambda, you can call it a, you can call it b, you can call it whatever you like. The problem with this equation is that it is not a linear equation. It's an exponential decay function. It's a y This is for people who knows a little bit of mathematics. It's a y equals e power minus x function. This is an exponential decay function where you have a value and it decreases quickly over time, but it's not linear. This is not a linear relationship. This is a curve, okay? And people, what they like to do is they like to linearize this equation. They take len both sides. They go like len a equals len a0 times e power minus lambda t, and then that will break down to len a0 plus len e power minus lambda t. Sorry, I'm writing using my mouse, so forgive me for that. Sorry, I'm writing using my mouse, so forgive me for this, for the bad font. And then the len will go out, so that will go len a0 plus, or it's gonna be minus lambda t, right? And it will be minus lambda t, and then you have an equation like looks like this. It's a first order equation, first order kinetics, and then what they need to do is and then what they do is they consider this is your y and this is your x, and they plot len concentration times time, and they will be able to obtain a straight line. We're not going to do this, okay? This linearization, many research recently proved that this is actually not correct. You cannot do this, okay? Because it will introduce so many errors. We teach this to students in first year and maybe high school because it's easy. But sometimes simplifying things in science might not give you what you want. Also, this equation is easy to linearize because this is an easy model. But imagine that you have a model that cannot be linearized easily. Like imagine that you have, let's say, y is equal ax plus bx squared plus cx cubed divided by, let's say, 1 plus e power x. That would be a nightmare to linearize something like that, and then in that case you must do what we call nonlinear fitting. So the example that we have here, I have already some data between time and concentration. The relationship is not linear. You can just plot this in Excel and you will see yourself. So you see this is a line, this is a curve. So I'm gonna teach you today how to do nonlinear fitting in Origin. Okay? So same thing. We go to Origin. We start with what we know already. I'm just gonna hide all of these previous stuff. Okay. I'm gonna make a new sheet. So new window, new worksheet. I'm gonna call this kinetics data, whatever, just something. And I'm gonna bring my numbers. So Control C for this. Put it here, and I have time and concentration. With the long name, the time would be in, let's say, hours, minutes. It should be maybe minutes, and the concentration would be in molarity. And if it's a radioactive element, you can do alphabetic particles. It depends on your, of course, on your stuff. Now, if I plot this using the points, by the way, never. As a piece of advice, never use lines or lines and points to and by the way, never use lines or lines and points to depict data, experimental data. That's wrong. Because in that case, you're assuming that this line is the correct one to connect these points, and this is wrong because you don't know that. You don't do that. You don't know that. The correct thing to do is you plot the points only, okay, and then you choose a fitting that mathematically can connect these points in a continuous function. So for our nonlinear fitting, what we need to do is we go to analyze and then fitting, and in here you have too many things, but I'm gonna choose this nonlinear curve fit, and then I'm gonna open the dialog. And in opening the dialog, I'm gonna change this into auto first, okay? And in here, my data is already these data, okay? For the function, you have so many options for functions in Origin. Let's say what we call previously made functions. Okay, look at that. Let's say polynomials. Okay, you have a lot of polynomials functions already in there. So you have the cubic function, you have the line, and you have so on. You might be lucky in finding an exponential decay function here already. But what I'm going to teach you today is how to make your own function. I know already that my equation is that it is y, it's this equation, right? Which is an easy equation to write down. It's y equals an a0, which is constant. Let's call this a, small, times exponential, let's say minus bx. That's your function. With the two parameters a and b, these are constants, which we call the fitting parameters, and you have your y and x. So this is a very easy function to write in Origin. So I'm gonna go back here, and then I'm gonna click new. And with the new, I'm gonna save this into user defined. Don't save your function under these, okay? So I'm gonna save it into user defined, and I'm gonna give it a name. So I'm gonna call this dk, and then maybe underscore Ismail. That's my function now, okay? So it's gonna save that function into a file actually. So the destination is not important. He's gonna save that automatically. I'm gonna click next. Now he's asking you a couple of questions. He's asking you what is the independent variable and what is the dependent variable. So these are x and y's and the parameters. I have two parameters which I'm gonna call a, b. It's very important to name your parameters. I don't have derived parameters, so that's fine. So this should be it for your new function. You have x and y and a and b, and you click next. And he's asking you now to put your function. My function, remember, it is y is equal a times exponential open brackets bx, b times x. This is the correct way of writing the function, okay? If you need log, if you need len, if you need anything, you can search the help and see how a function is written. But for this one, it is straightforward. Now click next. In here, he's asking you, that's not important, but in the next page, this is very important, by the way. Sometimes the nonlinear fitting works right away, but sometimes you have to specify, for example, if a and b should be positive, or because sometimes depending on the model, these parameters can take different values. But in our case, these are positive, okay? So you can specify this, you can specify lower and upper bands and so on. But for us, it should be straightforward. So I'm going to click next and then finish. I have my function ready to go, and then I'm going to start something we call iteration. Because if you studied statistics or mathematics, that's kind of optimization thing, is that the program will now try to optimize these data according to your function. So I'm going to click once here. So I'm going to click here, keep clicking, and you see something is wrong, okay? Because this is all the red messages and something is not working. And now I remember that I made a small mistake, and forgive me for that because people make mistakes all the time. So that's fine. Is that we forget the negative sign in the function, okay? And I the way you fix this is you go and edit your function. And now remember that here the function was y is equal a exponential bx. Now we forget just to put the negative sign here because the formula is negative, okay? And I click finish, and now we're gonna start. Oh, okay, now it looks good. So click iteration, 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 and then maybe click, and then this will this will fit until converged. Okay, if you click that, oh nice, okay, see that? It's beautiful. He actually did the linear fitting for your data. Now if you click OK, remember it's auto, so click OK. Now I have something similar to before, but now look at this. Origin is telling you some stuff. That the model he used is a DK Ismail model, the one we created, with this equation. He's giving you the equation, and this is your A and B. This is your parameters. This is your A, which is the concentration, the original concentration, A0. He's telling you that according to this fitting it is 2 plus minus something. And this is your B. This is your lambda, the fitting parameter. And if you have a model with 3 or 4 or 6 parameters, that will give you that. And he's giving you an adjusted R square, which is equal 1, which is perfect. So this is what we call a nonlinear fitting that you should use instead of your linear fittings. And you can adjust this curve and format the way you like. The final example that I have here is for adsorption, and this is for chemistry, and again it's nonlinear fitting. Okay, and people who studied adsorption, they know about Langmuir, which is a very famous equation for Langmuir. This is the one. It's Q equal Qm, which is a constant, times Kl, which is also a constant, times the concentration, which is your X, divided by 1 plus KLCE. This is a non-linear equation. This is not a linear equation. This is something that people get scared of. So what they do is they go and linearize this. They do some math to change it to that, and then they plot the value of CE divided by QE versus CE, and they get a linear graph. Again, many research recently proved that linear fitting or linearization of nonlinear equation or nonlinear curve is actually introduce so much errors to the process. So the correct thing to do is to think about this data. I'm gonna plot this data, okay, just to show you how they look like. This data came from an experiment and they look like that. This is how the data originally are. So common sense says that if this data makes a curve, why you want to make it a line? This data is a curve, so you want to fit it into a curve. So the way you do this is you take this data. Again, I'm gonna just do this quickly this time because I think you know what I'm doing. So this is a worksheet, a new worksheet. I'm just gonna close this graph for some. I'm not gonna delete it. I'm not deleting stuff. I'm just hiding. Okay. So I'm gonna bring this data into Origin, my lovely data, and then QECE. Put it here. They have units. You can choose the units. I'm gonna make my graph. Don't ever make lines. Okay. Don't do that. This is wrong. Don't do this. Unless if you wanna show. Unless if you have a message of delivering this. Okay. But in this case, we need to do fitting. So I'm gonna make the point, scatter point graph, and then I will do the non-linear fitting for this data depending on this equation. Now let's think about this equation. Let's make an equation in terms of y and x that looks similar to that. So this should be y, this is your variable, equals bunch of constants. So I'm gonna call this q. By the way, you don't have to choose A, B, C. You can do whatever constants you like. I'm going to just call this Q times K times X divided by 1 plus Kx. So that's my equation. That's my nonlinear curve, okay? That's a curve. So let's see how we're going to do it. So analyze, fitting, nonlinear curve fitting, and then open dialog again. I'm gonna make a fitting for this. By the way, I have used this before. You see I have my own functions here, and it looks like I've made a function in the old days that calls Langmuir. So let's see how this looks like maybe this is the one we use, so I'm gonna edit this function. Oh, cool. So this is your same thing, x and y, and this is qk. Okay. And look at this function. You can take a snapshot of this and remember that. So this is a y equals q times k times x divided by 1 plus kx, but the brackets are very important in here. It's very, very important that you use brackets in a correct format in order not to make a mistake, because if you don't use these parentheses, Origin will get confused and then you're gonna get into trouble. This is okay, I have not used anything here, so this function looks good to go. So let's try it. This is manual, so I'm gonna change it to auto, and nothing in here because we have not started the process yet, the process of filling. So here you go, one iteration. This is a line, and okay, let's put it here so you can see. Oh, okay, nice. And now it's not working. Now it is not working. Why? Because probably there is something wrong with the parameters. And this is the most important thing that I want to show you today, is that how you push fitting or make this works. So the way you do that is you go to edit the function again and you click next, and you go to that window where you define your parameters. Remember this? Okay. Now depending on your science, by the way, I'm just gonna do cancel here for a second, and because I want to move this graph here so you can better see what's going on. Analysis fitting, nonlinear fitting, open dialog, auto. So I'm gonna choose the function that I have already chosen, Langmuir, and so we are here. Remember here that you have a chance to tell Origin what these parameters are. Of course, depending on your model and depending on your science, things different, but in my case, I think this k is lower than 1. So here I'm gonna tell him that this is between 0.01, let's say, and 0.8, and this is bigger or equal, smaller or equal. Okay, and this q, I remember it should be big, like bigger than 1. So I'm gonna here 1, and maybe I'm just gonna tell Origin that this is actually positive numbers. So I'm not gonna put an upper limit, and let's see, let's try an error. Okay, so click finish, and let's start again this. Okay, see, it's working now, because Origin is a software. He doesn't know any science. You know the science, he doesn't know your science. Okay, you have to give him some kind of initial parameters that can help him into the fitting. So click here, click there. Okay, see, it's working now, and now okay, and you're done. Now he fitted your data into this nonlinear fitting graph. Okay, and he provides you with the equation again that he's using for the fitting, and your q and your k, and so on. And what I need you to do, if you're working in adsorption or in any model that you're using, and you're still using this linearization thing that before, I advise you to do both. Like, you do the linear fitting and the nonlinear fitting, and see and compare the values that you obtain for both methods and the R-square, and do your own research about that. The final thing I want to teach you today is that sometimes if you're doing this experiment 3 times, you should have, remember, this is your x and this is your y, right? So if your supervisor is asking you to do this experiment, let's say 3 times, and you calculate the percentage error between the 3, okay? So let's say that or what we call the standard deviation error, right? Remember that? So let's say that the standard deviation here, I'm just gonna throw any numbers, that between the three trials you obtain standard deviation of, let's say, 0.1, 0.2. I'm just gonna throw numbers here, okay? Okay. Now, I have some errors that are associated with my measurements of the QE. So in Origin, the way you introduce these numbers, which we call the error bars, into this data. By the way, to do this, I'm going to just delete this curve fitting I did. So delete. That will delete everything, as I said before. Now I'm going to insert a new column, and this column, that would be my Y error, they call it. So if you right click here, and that will say set as, you want this X, Y, or Z. Neither of this. I'm going to choose this as Y error. So this is my standard deviation error. So I'm going to copy these numbers and put them here. By the way, Origin, you can add as many as you want columns. You call them X1, Y1, X2, Y2, and whatever. It's a huge program. What I'm going to do here is I'm going to make another graph using the 3 columns. And the errors are too small. They are there, by the way, but they are too small. So maybe, okay, these numbers are not actually good for this data. Okay, so I'm gonna copy this again, put them here so you can. Okay, so this is something that you might saw before in papers, that the error bars, these error bars are associated with your measurements. This is a standard deviation for each measurement. Okay, and you see this one, for example, it's maybe there's so much error here, but anyway. The nice thing about Origin is that when you go to analysis and you go to your nonlinear curve fitting, is that the program will actually include these error bars into the fitting. So it's not only fitting the points, the data points. He's also using these error bars into the fitting in a very complex mechanism. So you might also need to do that. That's it for now, and I wish you like this, and we'll see you in future tutorials. Thank you.